All right, Algebra 1B students, welcome to part 2 of your video on lesson 12.6. We're continuing our talk about combinations and permutations. In the last video, we talked about combinations of things, how many different combinations of 8 shirts and 5 pairs of shorts you could do, and things of that nature. Now, the important thing is, in those situations, the order didn't really matter. Right? Changing the order didn't really change the thing that you were dealing with, right? Whether you picked the shorts first or the shirt first or the color of the shorts, it didn't matter. In this video, we're going to talk about something where the order actually does matter. That's called a permutation. Okay, a permutation is an arrangement of objects in a specific order. Okay, the order in this case is very, very specific. Now, they show you an example here where they have organized the letters A, B, and C, taking all 3 of them and mixing up the order without repeating any letters. There are 6 ways that we can do that. Okay, there are 6 ways for us to do that. You can do this, 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 right? 6 ways to arrange those letters in order. So now we're not talking about choosing things necessarily anymore. We're talking about ordering things in a specific way, in a specific order, right? And that is what we call a permutation. Permutation. Now, when we want to find a permutation, we have to make sure we label the things in a specific way, okay? Because the order of those things really does matter. So, for example, if you want to figure out how many different batting orders you can have with 9 players on a baseball team, we have to arrange, okay, player 1, player 2, player 3, player 4, player 5, player 6, player 7, player 8, player 9. There are 9 players on a a baseball team. Now, if I want to choose who's going to go first, I have 9 players I get to choose from, right? So let's say, for example, I pick player number 4, okay? Remember, I had 9 choices for the first player, and I chose player number 4. Now, for the second player, I can choose anybody else, but I can't have player number 4 bat again. So I can't repeat player number 4. So I only have 8 choices left for the second batter. And let's say I choose player number 8. Player number 8 is now gone. He's batting second. So I had 9 choices for the first batter. I have 8 choices for the second. And if I look for my third batter, I only have 7 players left. 1, 2, 3, 5, 6, 7, and 9. And as I continue down, I get less and less players as options, so that by the time I'm done, my last player has already been chosen for me, right? It has to be player number 6, because that's the only player that's left. So my one choice at the end is for my 9th and final batter. Now, in order to figure out how many different ways we can do this, I take all of those choices that I just talked about, 9 choices for the first batter, 8 choices for the second batter, 7 choices for the third batter, and so on, and I multiply all of these things together. Multiply, 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 multiply. I do 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That ends up equaling a very large number. 362,880 different ways to arrange those batters. Okay? 362,880 different batting orders with those 9 players. Pretty big number, actually. But that is how we find permutations. If we want permutations of how many ways can we arrange these 9 things, we do 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If we want how many different ways can we arrange these 5 things, we do 5 times 4 times 3 times 2 times 1, and so on and so on and so on, because our choices get more and more limited as we pick the things and place them in the order. All right. So here's one for you to try. If you have a swimming pool that has 8 lanes, how many ways can 8 swimmers be assigned to the lanes for that race? So remember, you got racer or swimmer 1, swimmer 2, swimmer 3, swimmer 4, swimmer 5, swimmer 6, swimmer 7, swimmer 8. And you have to arrange them in whatever order you want. Okay? So pause the video for a moment, take a look at that problem, and then coming back and I'll show you what we should have. Okay, in order to arrange these people, we do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. What do I end up with? Some other big number. 40,320. So there are 40,320 different ways to arrange those 8 swimmers in those lanes. All right? Now, what does all of this really mean? Right? What is it? There must be a simpler way to write this. I'm sick of writing 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So, somebody a long time ago came up with this idea of something called a factorial. Factorial, like 9 factorial is the answer to number 2, you know, the 9 batters. N factorial, for whatever number it is, we just write that number with an exclamation point. And it's all of the numbers that are that number and smaller multiplied together. Okay? By the way, 0 factorial is defined to be 1. Just because it is. Okay? But n factorial, or n exclamation points, is just equal to n times the one before it, times the one before it, times the one before it, times the one before it. So, for example, 14 factorial is a very, very, very large number. It equals 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And it ends up being a very, very massive number. I'm not going to make you do it. It's almost too big for the calculator. It's in the billions. So factorial is a nice way to write all of this together, right? Instead of writing all of this out, I can just write 14 factorial and I'm done. So for number 2 that you did about the swimming pools, if you want to write 8 factorial as your answer, I'm fine with that. For this, if you want to write 9 factorial as your answer, I'm fine with that, as long as you can prove to me that you still know how to find it and what that really means. All right? If you have questions about permutations or factorials, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.